This is BYU Math 112. In this video we will discuss textbook section 2.8, exercises 21 and 26, which have the same directions. Find the derivative of the function using the definition of the derivative. State the domain of the function and the domain of its derivative. So we look at number 21, f of x is equal to 1/2 x minus 1/3, which we note is a line, and therefore its domain is going to be everything. And now we use the definition of derivative given here to find its derivative. So we have f prime at x is equal to the limit as h approaches 0 of f of x plus h. In this case will be 1/2 times x plus h minus 1/3 minus the f of x. So minus 1/2 x minus 1/3 all over h. And so we note that we're going to be distributing this 1/2 to the x and the h. And we have a negative 1/3. We're going to be distributing this negative sign to the 1/2 x and the negative 1/3. And so our 1/2 x is going to cancel with the 1/2 x, and the 1/3 is going to cancel with the 1/3. And so all we have left is the limit as h approaches 0 of 1/2 h over h. And so obviously these h's are going to cancel out, and the limit as h approaches 0 of 1/2 is just 1/2. And therefore f prime of x is equal to 1/2. If we look at the domain of the derivative, it's just a constant function, so its domain is also going to be negative infinity to positive infinity. Next, we consider number 26. This one's going to be a little more involved with a little more algebra. G of t is equal to 1 over the square root of t. So the domain of our function is going to be where the denominator is not 0, so t can't be 0. But then we have a square root function, so t needs to be non-negative, so our domain for our function is going to be everything from 0 to positive infinity. And now we use the definition of derivative. So in this case we're going to say g prime of t is going to be the limit as h approaches 0 of the f of t plus h. So in this case it's 1 over the square root of t plus h minus the f of t, or g of t, sorry, 1 over the square root of t all over h. So on the top we're going to get a common denominator, the square root of t times the square root of t plus h. Then we're going to bring the h up, so what we have is the limit h approaches 0. On the top we're going to have the square root of t minus the square root of t plus h. On the bottom, again, we bring the h up, we have the square root of t and the square root of t plus h. So if we look at taking this limit, again we're going to get 0 on the top and 0 on the bottom, which is a problem, so we have to rationalize the numerator. And so we're going to multiply on the top and bottom by the square root of t plus the square root of t plus h. On the bottom, the square root of t plus the square root of t plus h. And what that's going to give us is the limit as h approaches 0. When we multiply the top, we have a difference times a sum, which is going to give us the difference of two squares. So we're going to have t minus t plus h. And on the bottom, we just have that whole lengthy thing, h root t plus h times the square root of t plus the square root of t plus h. So on the top, distributing that negative sign, my t's are going to cancel each other out. And so I'm going to be left with that negative h up there. So we have the limit as h approaches 0. So I have a negative h, and I have an h on the bottom, so I can cancel the h's out. So what I'm left with is negative 1 over all that stuff that's left. Square root of t plus h, and the square root of t plus the square root of t plus h. Now when I take the limit as h approaches 0, I can substitute in 0 for h in each of these parts and kind of see what happens. It's not going to cause me any problems this time, so I'm going to have negative 1 over the square root of t times the square root of t times the square root of t plus the square root of t. And so when I work that out, what I get is negative 1 over the square root of t times the square root of t is going to give me a t. The square root of t plus the square root of t is going to give me a 2 square root of t, because I'm just counting those, adding those together. So I have 2t to the 3/2 power. Again, that's a t times 2 square root of t. So this is t to the first, this is t to the 1/2 power here. So I'm just adding those together to get my t to the 3/2 power. Alright, so then I have g prime of t is equal to negative 1 over 2t to the 3/2 is my derivative by definition. And again, what is the domain of that function? Well, again, I have a t on the bottom, so I can't use 0. I have a square root still, that 2 on the bottom of my fraction, so I can't have anything negative, and so the domain of the derivative is also 0 to infinity. Now, does it always work out that the domains of the function and the derivative are the same? No, it doesn't. In this case, it did. But I encourage you to memorize this definition of the derivative. You will need it in the future. And that's how we find the derivatives using the definition.